The second type of variation, as mentioned in the previous video, is the inverse variation, which states that an increase in x causes a decrease in y, and a decrease in x causes an increase in y. An example is the speed of a car and its time of travel. As the speed of the car increases, the time it travels decreases. Same as when the speed of the car decreases, the time it travels increases. Anna lives 40 kilometers away from the office of ABC Corporation where she works. Driving a car, the time it takes her to reach work depends on her average speed. Some possible speeds and the length of time it takes her are as follows. How do speed and time of travel affect each other? Based on the given table, we can observe that as Anna speeds up, it takes her less time to go to work. Also, as she speeds down, it takes her a longer time. In other words, as the speed increases, the time of travel decreases. Same as when the speed decreases, the time of travel increases. The previous example leads us to conclude that inverse variation occurs whenever a situation produces pairs of numbers whose product is constant. Let us take a look at this table of values. If you travel at the speed of 5 kilometers per hour, you will arrive at your destination after 1 hour. Multiplying the two values, 1 and 5, this will give us a product of 5. Same as when you travel at the speed of 10 kilometers per hour, you will arrive at your destination after half an hour. Let us multiply the two values, 1/2 times 10. This will give us a product of also 5. If you travel at a speed of 15 kilometers per hour, you will arrive at your destination after 1/3 hour. Multiplying the two values, 1/3 and 15, this will give us a product of 5. If you travel at the speed of 20 kilometers per hour, you will arrive after 1/4 hour. Multiplying 1/4 by 20, this will give us a product of 5. Lastly, if you travel at the speed of 25 kilometers per hour, you will arrive at your destination after 1/5 hour. Multiplying 1/5 by 25, this will give us a product of also 5. The product of the pairs of numbers of this table of values is constant because the product are all equal to 5. Therefore, we can say that this table of values represents an inverse variation. Furthermore, we can say that in inverse variations, for two quantities x and y, an increase in x causes a decrease in y or vice versa. The statements y varies inversely to x, y is inversely proportional to x, both translate to y equals k over x, where k is the constant of variation. Find the equation and solve for k. Given y varies inversely as x and y is 6 when x is 18. First, we have to translate the statement y varies inversely as x as the mathematical equation y equals k over x. And then we will use the given values y is 6 when x is 18 to substitute it and solve for the value of k in our given mathematical equation. Now to do that, the value of y is 6, k will be retained, and x is 18. And then solve for the value of k in this equation. To do that, we have to multiply 18 to both sides of the equation and then simplify. We may cancel this out. K will remain, and then we have to solve for the product of 18 and 6. and that is equal to 108. Therefore, our constant of variation, which is k, is equal to 108. Now, to find the equation of variation, what we have to do is to substitute the value of k to our variation equation y equals k over x. Substitute the value of k, which is 108 over x, and this will be our equation of variation. If y varies inversely as x and y is 10 when x is 2, find y when x is 10. First, we have to translate the statement y varies inversely as x to the mathematical equation y equals k over x. And then we have to use the values of y, which is equal to 10, and x is 2, and then substitute it to our equation y equals kx to solve for the value of k. Now, doing that, in this equation, y will be equal to 10, k will be retained, and x is equal to 2, and then solve for the value of k. To do that, we have to multiply 2 to both sides of the equation and then simplify. We may cancel this out, k will retained, and then find the product of 2 and 10, and that is equal to 20. Therefore, our constant of variation is 20. Now, we will use this value to solve for the value of y when x is equal to 10. Again, we will be using our equation y equals k over x. This time, we will use the constant of variation or the variable k. We have to find the value of y when the value of x is 10. And then using the constant of variation 20, that will be the quotient of 20 and 10. Simplifying this will give us a final answer of 2. Therefore, we may say that y is equal to 2 when x is 10.